Hi, welcome to Lab 5 of the Serverless Machine Learning course. In this lab, we're going to go through some fundamental concepts in machine learning operations, or MLOps. So what we're going to actually cover is versioning. We're going to cover versioning of feature groups. So when we make a breaking change to a feature group, maybe we're going to drop a column, we're going to change how we implement a particular feature, then we'll need to create a new version of that feature group so that we're able to keep the old version, keep any pipelines running on the old version, any training data sets created with the old version, any models running with the old version of the feature group. But the new version, we're going to have to fill it up with data. We're not going to mix the data from the old one to the new one. And we're also going to have to then use that in our new updated feature pipelines. We're also going to look at how we validate data in feature pipelines using great expectations. So we're going to look at some validation rules for great expectations and add it to our credit card fraud example. And then finally, we're going to finish with testing of feature logic and feature pipelines with PyTest. So let's get started. What you'll need to do to get started is, of course, pull the latest changes from the ML course repo to your forked version of the repo. So we've done this before in the previous labs. I hope it's pretty straightforward. And let's get started. So we're going to get started by looking at the very first example that we covered in Lab 1, which was Iris, just to see what great expectations is like. If we took the most basic notebook we could have, which is Iris, how would we add great expectations support? So let's go into and look at that. So I'm going to start by, firstly, I've pulled the changes already. So I'm just going to start by running a Jupyter notebook. And we can see here we've got the Iris feature pipeline with great expectations. So in this particular notebook, if we look at it, we can see that I can set backfill to be true or false. I think I don't have great expectations already here in my repo, or my fork of the repo. So it should actually, great expectations should be there, but I'm going to run backfill equals true. So it's going to create a new data frame with all of the Iris flowers rather than running it in the mode that we call production, where we get a new random flower on every run of the pipeline. So in this case, we're backfilling with some historical data. It's the Iris features. So now we'll get into the real difference. So assuming we know what the Iris flower dataset is, we've got three different types of flower. We have Setosa, Virginica, and versicolor. We want to define some rules for what makes a valid one of these flowers, the versicolor, Setosa, or Virginica. So one thing we can do when we create, even if we create a random flower, so we had this synthetic data generation for random flowers, was, well, what would make up a correct flower based on the data set that we have? And one way of looking at it would be that if we take the four features that we have defining these Iris flowers, we have the sepal length, sepal width, petal length, and petal width. What was the minimum and the maximum values of these features for all of the flowers? Well, I've actually filled in the details here. We can see that we have 4.3 is the minimum sepal length and 8.0 is the maximum. And the same is true for sepal width, petal length, and petal width. We have the minimum as the first entry here, and then the second entry, or second of these parameters, is the maximum value. So what we want to do is basically define a single expectation suite. This is our expectation suite, and we can get it by creating an expectation suite object using great expectations, which we've imported here as GE. That's pretty much the de facto way of defining GE. Like we would import pandas as PD, we're going to import great expectations as GE. So we're just going to give a name to that expectation suite that we create. We're calling it Iris dimensions. And then we're going to define this particular expectation rule. So what we're going to do is it's going to take in an expectation suite, the column name that we're interested in, the min value, and the max value. So this is our function called value between. This is a Python function I wrote, because what I want to do is I want to create lots of expectations, one for each of the four features in our data set. So I'm going to call my function value between, with the expectation suite as a parameter, the name of the column that this expectation rule would be applied to, the first parameter, which is the minimum value, and the second parameter, which is the maximum value. So when I call this function, the first time it's going to create an expectation and add it to my expectation suite. So you can see here, adding an expectation to your expectation suite is as simple as calling add expectation. And then we have to put in information about the expectation. Well, firstly, we have defined one of the expectation types. Now, there are many different expectation types in Great Expectations. One of those is expected column values to be between a minimum value and a maximum value. And all we need to supply apart from the minimum and the maximum value are the column name as well. So these are the three parameters I pass in when I call value between. It's going to create an expectation, add it to the expectation suite, and I just need to specify then the feature name here. That's the column name in our data frame, the minimum value and the maximum value. So this will create 4 expectations that will all be added to the expectation suite. And let's run the code if we haven't run it already. So now I have an expectation in a suite in Great Expectations. This is very standard vanilla Great Expectations code, nothing to do with Hopsworks or Pandas. We can move on, and now we're going to see how we can declaratively attach that expectation suite to our feature group. So we've done this before. We're going to create a feature group in Hopsworks. You can see I can specify the version number. I'll call it 6 because I've been playing around with different version numbers. In this case, the primary key is all 4 of the columns because there's not a unique ID column. So we'll just create a primary key from the combination of all of the column values. And you can see here, this is the new code that we're adding. We're adding the expectation suite, and we're saying, for this feature group, I would like to attach this expectation suite object that I created here. This is the expectation suite object here. So it is one expectation suite per feature group, but once I've attached it, and here we just created our feature group, when I now write a data frame to the feature group, it will execute all of these expectations before it writes to the feature store. So I can call the code here, and you can see it started. It's inserting the code, it's uploading the data frame, and we can see the results of the expectation suite. So in this case, it evaluated 4 expectations that were the 4 different features. You can see we had 1 successful and 3 of them were unsuccessful. Okay, that's interesting. So we're only successful 25% of the time. Let's see what happened. So we can see that it says here that if we go down, a success false, which is one we're interested in, we want to find out why did it fail. Well, we can say, okay, there were 5 unexpected values. There was 3% of the total, and you can see that the problem was that there was a value of 0.1. Okay, 0.1, what was that for? Well, it was for the petal length. And we can see here that for the petal length, we had 5 values which were 0.1. Okay, that's quite a low petal length, quite a small petal length. We can see that we'd set the minimum value to be, or sorry, it's not petal width, petal width, sorry. Okay, we'd set it to be 0.2, but we had 5 values which appeared which are 0.1. That's not great, but that happens. You can see here for petal length, success was false, and that was because we had 2 values which were 1.1 and 1.0. So it's supposed to be minimum value 1.2, but the petal length that appeared was 1.1 and 1.0. Okay, we need to maybe reduce those two. So petal width should be 0.1 and the petal length should be 1.0 if we want these errors to disappear. And if we go to the next one, we can see that we have success false for sepal width. So it says minimum 2.1, max 4.5. That's here. And the unexpected value was 2.0. So we need to reduce that sepal width to be 2.0. And then finally for the sepal length, we can see that it was true. So all of the values fell within this range, 4.3 and 8.0. So let's go back and make the changes and see if we can fix them. We're going to set the, in this case, the sepal width to 2.0. We're going to set the petal length to 1.0. And we're going to set the petal width to 0.1. Okay, let's go ahead and do that. And we'll run it again. So this is the sepal width 2.0. Petal length 1.0 and petal width 1.0.1. Now, to do this, we can create a new version of the feature group. That would be the easiest way to do it. The other way to do it is to delete our expectation suite on the feature group. We can run this, and then we can recreate. We can get the feature group back again and reattach the expectation suite, and off we go. Now we need to make a separate call on the feature group object to attach the expectation suite. So you don't have to just call the create feature group method and have the expectation suite here. There's another call to, and we can see it in the docs if we have a quick look in the docs. To the API for the feature store here. So if we go to our feature group, we'll see that there is a method here. You can call it. So you can see we've got delete expectation suite, and then we have save expectation suite. So the save expectation suite attaches an expectation suite to a feature group. So you can use that call as well, and you can pass in the expectation suite object. Another thing you can do as well is you can, when you're ingesting the data, when you're writing the data to the feature group, the default validation ingestion policy is always, but you can change it to be strict, which means it will only insert the data if it passes. If we have it to always, it's a looser data validation rule. It means we'll ingest the data, but you'll get your warnings. Let's actually have a look at the warnings because I just ran this here and see what it looks like. You can see this is the feature group that I created. And if we go down here, we'll see that, okay, we've got 3 unexpected expectations. We've got 25% success rate. And I can have a look in a bit more and see, well, it was the petal length, sepal width, and petal width that were the problems. Sepal length was okay, that one was success. And you can download the report from there as well. Okay, let's go back and I'm going to create a new version of the feature group just because we want to cover creating new feature group versions as well. We'll see how that works. So what I'm going to do is just going to go back here and rerun this code. So let's remember it was the sepal length was okay, if I remember correctly. Let's have a quick look. Sepal length, that's okay. And we change the values for petal length, sepal width, and petal width. Okay. So I'm going to recreate this object, run that cell again. We can log in again. I don't know if we need to log in again, the feature store, but I'm going to create version 7 of the arts feature group. So you can actually do this in Hopsworks. You can create multiple versions of the same feature groups just like this. And now when I insert the data into the feature group, again, it will run Great Expectations. So what it's going to do is upload our feature group to the feature store. It's running our Great Expectations rules, and let's see what we get. So here we evaluated 4 expectations, but this time they were all successful, none were unsuccessful. So changing those ranges of expected values for these 4 features into the minimum that we saw in the data set to the maximum, now we're confident that it's okay. So typically how we'd use this in a production system is you would determine with some domain knowledge what minimum values would be for a feature and maximum values would be for, in this case, a numerical feature. And then if for some reason some data is created that invalidates that expectation or assumption, then depending on the validation policy you have, whether you say, well, no, I'm not going to ingest it, or I'll just ingest it and get a warning and see, or an error, and then I can see what I'm going to do about it. And that's typically how you would run it in production. So let's go back and have a look here. So this was our feature group here. Now, this is where we get into the MLOps versioning of feature groups. So I created version 6 here. And if we go back and look at our feature groups, and we can see that version 7 was created of this particular feature group. So if we click on this, we can see version 7, but I can go back to version 6 if I want to. Both are still there. And both can have their different tables effectively, so they can have their different sets of data. We can see in this case, there were 4 expectations evaluated when we wrote to the feature group, and it was successful. So all these were successful, but for version 6 that we created earlier, we saw that we had the failures. We had because the range of the values in our expectations were exceeded for 3 of the features. So for the petal length, sepal width, and petal width. Okay, that's the starting point. So now if you've run this notebook, it's in as we saw it, it's in here in the 05. So this is the folder for this is actually module 05. So 05 module in the source code directory. You can run this one to get warmed up with. Let's have a look, and we'll move on to the next part of the lab. So we'll look at our feature pipeline from the credit card example. Now in this case, we're going to imagine a scenario for the kind of MLOps issue that you can have. And MLOps is really here to help us when we get changing requirements, when we need to maybe improve something, we maybe have to update the code. And it might be updating the features that we're going to use in our model. In this case, we're assuming we heard from our compliance team. They told us you're not allowed to use the credit card holder's age anymore as a feature. There's a new law or regulation that's been introduced and says we don't want to bias it against people based on their age. So what we're going to have to do is delete that feature from the transactions feature group. Okay, let's go ahead and look at how we would do that. So we had two feature pipelines and that we used to create the transactions. This is back from lab number 2. The first one here we can see is what we call backfilling. We have some historical data about features that we can use to create and backfill or fill up our feature groups with historical data. And you can see here that we had in the previous version we were creating. This is the same notebook as in lab 2. We can see we say version 2. So we've been told by compliance we're not allowed to use the credit card holder's age as a feature. So we're going to remove it. And you can see I've commented out, in this case, the card owner age as a feature. We're not going to create it this time. So what we're going to create instead, we'll see. This one I ran already. Here we go. And we're going to keep the same features we had as before. And what I've added this time, you can see here, is an expectation. So we can see that we only have 2 expectations that I've added. We're using the same kind of way that we add expectations before. I have a function that I defined, which takes the expectation suite as a parameter, column name, min and max values. And it's adding the expectation to this expectation suite object we've created here. So I'm just validating the credit card number is in the range. In this case, it's a 16-digit number in the range 1 with 15 zeros after it to the maximum 16-digit number, which is all 9s. It's not a great way of validating credit card numbers. You should use a library for that. This is just for educational purposes. So the second way of validating was to calculate the number of days until the credit card expires. And credit cards can expire and still be used for a day or two potentially. So actually the data set has a couple of negative numbers. That's why I start at -3. But then 365 or 36,500 days is 10 years, and most credit cards are not valid for that length of time. So we want our credit card expiration time, or days until that credit card expires, to be within that range. So we'll create this expectation. We'll do the same as before. We'll connect to the feature store. We're going to use the same window aggregations data frame that we had in lab 2. And now what I'm going to do is I'm going to change the version. So one tip you can do is sometimes if you're using the version numbers in other cells later on, maybe you're creating a feature view from the feature group and you want the version number of the feature group later on, you can define it as a variable instead of defining it in here. I don't think I use it later on, so I'm just going to delete that. And I'm going to call this CC Trans Fraud version 4. And in this case, you can see I commented out the code for attaching the feature group, because you can create the feature group here without including this line here, where we're declaratively attaching the feature, the expectation suite to the feature group. You can also do it by calling the save expectation suite, and then you can specify the ingestion policy that you want. So for example, if you want strict as an ingestion policy, you can define it here and use this code instead. So I'm going to just do the same as we did with the iris case. I'm going to insert the data frame, and it'll validate the data before it writes it. And we can see also that it's the same as before. The only thing I've changed is because I've removed this age at transaction, I'm not going to add a feature description for it, of course. So let's look at whether it was successful or not. It says success false. Okay, so what was wrong? Let's have a look. So we have 50% success rate. 2 of the expectations evaluated, 1 was success, 1 was not. So the first one we had was success false. This was the day until cards expires. Minimum value -3, maximum value 36,500. So let's see what value was wrong. Well, we can see we've got some values here, -3 all the way down to -3.93. Okay, so what we can do is we can go back and say, okay, well, I seem to have got my range wrong again. That's twice I've done it. So what we can do is you can do the same as we did in the iris case. You can change it, and this time I think I'll just skip over it. But we can continue with the notebook as before, because I'm not too worried about that. We know how to rerun it, how to fix it. Let's add the feature descriptions. In any case, we get our feature group, and then we can do the same for our Windows aggregations feature group. We can go ahead and create those. And then we've got the labels feature group again. We can do the same. So let's have a look at how it appeared in here. So in this case, maybe you can say, well, okay, it was the CC trans fraud version that I created. We can see that we got 50% of the results are valid. We ingested the data anyway, right? Because you can see the configured in the always monitoring mode. That means that data is ingested independently of the validation success. I'm going to leave it here for the moment, because I'm okay with that. You can see the data is already in here. So if we click on data preview, we'll see the data is in our feature group. And you can see then that our age of the cardholder feature is now no longer in the feature group. Okay. So nice. We just created a new version of our feature group. We created some data validation rules with great expectations, and we wrote the data into the feature store. So that's pretty much all I want to cover for the data validation and versioning. You can play with this in many different ways. Now, feature views can also be versioned. So if we go back to our feature store here, we can see that we can create different, we can see it's version 1 of this feature view, and training data sets that we create from them, of course, can have versions. You can see I have 2 different versions of the training data created from that feature view. And if I create a new training data set, it'll be version 3 and so on. And you can actually delete these you can delete the training data. You can say delete all of the training data or only the data. So only the data means you can actually recreate it. So if you just click only delete the data, the metadata for creating that training data set will be kept. So you can press a button which will run a job to recreate that training data for you. The other place where you'll see versioning, of course, is in the model registry. So if you have models here, you can see we've got many different versions. This particular one, fraud, if I click on it, maybe we have a few different versions. Yes, you can see version 2, 3, and 4. And it says, well, version 3 seems to be deployed in this particular deployment. So we had a model deployment for it, but the other versions are not deployed. So they're all the versions that they're the most important versions, I think, that you'll see at least in the Hopsworks platform. But I think it's really generally enough to have version features and version training data and version models. That will get you most of the way to being able to build out a machine learning system that can be updated and upgraded while it's running, and enabling you to try out new features, new models, and being able to then seamlessly upgrade the system to new versions, and keeping the old ones running for the people who are dependent on the older versions. So let's finish by looking at how we test. In this case, we can test with PyTest. Now, there's a very good reading reference here if you're curious. If we open it up here, I say very good because I wrote it, but it's quite a comprehensive guide, I think, on how you can test feature logic transformations. So model-specific transformation functions, feature pipelines with PyTest. And there's a reference to a repository, and we have a different example here based on, in this case, converting IP strings to integers and how to test the feature logic for that, but also feature pipelines and transformation functions. But I'm not going to go through that. You can read that as an exercise. I'll just show you how we're going to use PyTest to test the feature logic. And we actually covered some of this in lab 2, and I'm not going to go into it in too much more detail, except we're going to look at how we can automate this as a GitHub action. So tests are great, and you can test the logic of your features. In this case, let's have a look at our test. But what we want to really do with this test, let's go back here. So what we really want to do with this test is have them run every time we push code to our repo, because we'd like to make sure that any code we push to the repo is correct. So I've already run pip install PyTest, and I'm just going to run the command to run our unit test here, python -m pytest. And you can see it's found 2 tests in this particular file, test_sml, test_sml. And I need to cat it to print it out. And you can see this is a test which is testing generate ATM withdrawal feature, and it's just validating that these two particular withdrawals fulfill the expectations of the test. So this second one is an invalid withdrawal, whereas this first one is a valid withdrawal. We want the unit test to ensure that. So if you were to change the implementation of the generate ATM withdrawal feature logic, and you break the assumptions of these tests, you'll be warned of it. You'll say, well, there's people who are depending on this feature. You seem to have made a change which breaks the expectations of the clients of this feature, the users of this feature. Maybe you should consider not breaking the test, because you're going to make a change of the features that makes it incompatible with the expectations of the clients. So you'd like this test to run every time you push code. So if I ever make a change to the test generate ATM withdrawal feature definition, that if I break these tests, then my test will fail, and I'll say, well, I need to maybe make a change to my code before I push it to the repo. So what we'd like to do basically is make this a GitHub action, and there's a GitHub action included in here called PyTest workflow. Let's have a look at it. And you can see the first difference is, well, when do we run the test? So the on command in our workflow says when the test should be run, and you can have the command on push, meaning when we push code to our repo. You could also enable the workflow dispatch if you want to run the test, maybe from the user interface in GitHub. And then the actual workflow can be the same as the workflows we've covered in previous labs. We need to install Ubuntu, check out our code, install Python, install the libraries that we expect to have in Python in this repository, and then we have a new line here. We're going to install PyTest. I wouldn't add PyTest to the requirements.txt file because you don't need it in the production workflow. So in our production feature pipeline, for example, we don't need it. So we only need PyTest in this particular workflow, which is the workflow that we use to test our code. So that's why we're going to include PyTest as pip install PyTest as a separate line. And then running the test is really what I did just a moment ago. I called Python -m PyTest, but I changed directory first to the folder or directory where the test folders are located. So this particular environment variable, the Hopsix API key, you'll need to have it set if you're going to also run feature or end-to-end pipeline. So running an entire feature pipeline that will potentially write to the feature store. And that's okay. You can do that. You don't have to mock your feature store. You can actually run this and write to an actual feature store. So it's testing the Python, the feature pipeline end to end. So that's your homework, which is to actually get this PyTest workflow running as a GitHub action in your repository, and then test it by pushing some code to your repo and checking to make sure that the tests run. And if you didn't push anything to break your tests, make sure then the tests pass. And you can also add nice elements, such as you can add a little badge in the README of your GitHub repo showing you that the tests have either passed or failed. So based on the status of that action, this workflow, the PyTest workflow, you can see immediately in the README, are my tests passing or has the most recent one failed? That's it. I hope you have learned something in this particular lab, and looking forward to seeing you in the next lecture, which will be on real-time machine learning.